All right, so this is the lecture for section 4.4 of MAC 2233 Applied Calc. So there are four rules in this section. The first one, basically this section is for exponential functions. And so the first one is that if y is equal to e to the x power, then y prime is equal to e to the x power. So in other words, the derivative of the function e to the x power is the same function as the original. Now, the second rule says that if y is equal to a to the raised to the x power, and a does not equal 1, in other words, a constant raised to the x power, is equal to, so y prime is equal to the natural log of a times the original function a to the x power. And of course, like I said, a is just a constant. The next rule, it says that if if y is equal to a raised to the g of x, where g of x is a function, then y prime is equal to the natural log of a times the original function a raised to the g of x times g prime of x. And then the last one is y is equal to e raised to the g of x, so then y prime is equal to e raised to the g of x times g prime of x. So let's look at number 2. So number 2 here we have y is equal to e raised to the negative 2x. So what we're going to do is we're going to let g of x equal negative 2x. So g prime of x is going to equal to negative 2. And so y prime, and so here we're going to use this last rule here, right? So if y is equal to e raised to the g of x, then y prime is equal to the original function times the derivative of the exponent. So then y prime is going to be equal e raised to the negative 2x times negative 2, which then we can write as negative 2 raised to the times e raised to the negative 2x. And so that's how you do, number 2. So number 6 is the same, all right? So we're going to go ahead and do that one now. So here, what this is telling us that y is equal to negative 4 times e raised to the negative 0.3x. And so what we're going to do here again, I'm going to define g of x to be negative 0.3x. So g prime of x is just going to be equal to negative 0.3. And so we're going to treat this as a constant, right? So I can remove the constant for a second and then kind of put it back in. So then y prime is going to be equal to negative 4, because we know that if y is equal to e raised to the negative 0.3x, then y prime is just negative 0.3x e raised to the negative 3x, right? And so this is negative 0.3 times e raised to the negative 0.3x. And then, of course, I can go ahead and multiply out the negative 4 times the negative 0.3, which will give me 1.2 times e raised to the negative 0.3x. And that's how you do number 6. So the next one is number 10. And so we're going to do the same thing, basically, that we did for number 6. Oops, sorry. And so here, I'm going to define g of x to be 4x to the third. So g prime of x then becomes 12x to the second power. And again, we can sort of ignore the constant negative 5. So then y prime is going to be negative 5. And then this is going to be 12x to the second power times e raised to the 4x to the third power. And so what we're going to end up here is with negative 60 x squared times e raised to the 4x to the third power. And that's going to be the y prime. So for number 16, we're going to have to use the product rule, right? And so I'm going to define this one to be my u. This one's going to be my v. And so if u is equal to 3x to the third minus 4x, then u prime is going to be equal to 9x squared minus 4. If v is equal to e raised to the negative 5x, then v prime is going to be negative 5 times e raised to the negative 5x, right? And that's how we have that one. So now, using the product rule, remember, if y is equal to u of x times v of x, then y prime is going to be equal to u of x times v prime of x plus v of x times u prime of x, right? And so here then, I'm going to come over here so I have a little bit more space. So y prime then is going to be 3x to the third minus 4x, right, times the negative 5 times e raised to the negative 5x plus e to the negative 5x times 9x squared minus 4. And so what we can do here then is I'm going to take out an e. Since I have an e raised to negative 5x here and here, I'm going to take one out. So it's going to be e to the negative 5x. And then it's going to be 3, sorry, that's not 4, that's a 3. So 3x to the third minus 4x times negative 5 plus 9x squared minus 4. I can clean this one up a little bit more. So it's going to be negative 15x to the third plus 20x plus 9x squared minus 4. And then the last cleanup here would be, here's my e to the raised to the negative 5th power. So it's going to be negative 15x to the third plus 9x squared plus 20x minus 4. And then so that's the answer for number 16. Now looking at number 20, of course here we're going to have to do the quotient rule. And so, oops, I don't know why it's doing that. So then what we're going to do is we're going to define the top one to be u. So u is e to the x minus e raised to the negative x, which means that u prime is just going to be basically e to the x, right, plus e to the negative x. So remember, if y is equal to negative e to the negative x, so g of x would be my negative x, so g prime of x will just be my positive one. Right, or my negative one, sorry. So then, of course, since there's a negative and a negative, it's going to be a positive, so then that's why we ended up with that. Then v is going to be x, which means that v prime is just going to be equal to 1, right? And so therefore, y prime is going to be equal to x, and in this case, it's going to be e to the x plus e raised to the negative x minus my original function, which is e to the x minus e to the negative x times 1 over x squared. And so I'm going to multiply out this x. It's going to be x raised to the ex plus x raised to the e to the negative x minus e to the x plus e to the negative x all over x squared. Right? Just kind of distribute that. Excuse me. And so what it looks like I can do here is, on the first one, I can take out a, well, let me combine some of these, right? So e to the x minus e to the x plus x to the negative x plus e to the negative x all over x squared. Take out an e to the x, which is going to be x minus 1. Take out an e to the negative x, which is going to be x plus 1. All over x squared. And so we can go ahead and leave number 20 just like that. So looking at number 24, I'm just going to use here, so I'm going to define, let's do g of t to be t to the third power. So g prime of t is equal to 3t to the second power. Then I'm going to define the inside function just to be h of t, which is e raised to the t squared plus 5t, which means that h prime of t is equal to 2t. Let me give myself a little space here. Let me just separate this so I have some more space. So this one then becomes my 2t times e raised to the t to the second power plus 5, right? And so now that I have that, it's just going to be basically, if you remember, is going to be if y is equal to f of g of x, then y prime is f prime of g of x times g prime of x, right? So f prime of t then is going to become 3 times e t squared plus 5t to the second power times the inside function, which is just going to be, if I multiply here, I have the 2t plus the 5, so that's going to be then 2t e raised to the t squared plus 5. Now, if I wanted to, I can just kind of leave it that way. We don't really have to clean it up anymore, simply because it would be just a little bit messier to do that. So again, that's just the derivative of if f of t is equal to et squared plus 5t raised to the third power. So the outside function would be t to the third, which the derivative is 3t squared. And then the derivative of the inside function, which will just be e raised to the t squared. The function is e raised to the t squared plus 5t, so then it's going to be 2t times e raised to the t squared plus 5. And so that's number 24. All right, let's look at number 28. So number 28, we're going to define g of x to be 3x squared minus 4, which means that g prime of x is equal to 6x. And then, of course, the constant is just going to be negative 10. So in this case, a is going to be negative 10, which means that y prime is going to be negative 10, right? Sorry, I'm going to do that again. It's going to be the natural log of negative 10. Actually, I can take out the negative 1. So it's going to be negative natural log of 10 times the original function, which is 3 squared minus 4, times the derivative of the original function, which is 6x. And so I can kind of clean this up a little bit. So it's going to be 6x squared, 3x to the fourth to the second minus 4 times the natural log of 10. So that's number 28. So number 30 here. In this case, let's say that a is equal to 2, right? G of x is equal to the square root of t minus 2, which means that g prime of x is equal to 1 over 2 square roots of t minus 2. So then here, s prime is going to be equal to 5 times the natural log of 2, that's my natural log of a, right? Times the original function, which is 2 raised to the t minus 2, times the derivative, right, of g prime. So it's going to be 2 times t, 1 over 2 times square root of t minus 2. So if we put all these together, we can end up with 5 natural log of 2 times 2 raised to the square root of t minus 2 all over 2 square roots of t minus 2. And so that's how you do number 30, following the rules that we have. So number 34, it's a little bit more involved, but f of x is equal to x squared over x to the third plus 2. So here I'm going to find g of x to be e. I'm going to write it this way so we can see that it is a fraction. So then that means that g prime of x is going to be end up to be x times 4 minus x to the third all over x to the third plus 2 raised to the second power. And so basically is the derivative of so it's going to be x to the third plus 2. Yeah, let me write it out. Let me write it out here and make it a little easier for everybody to understand. So g prime of x is going to be, right, x to the third plus 2, which is my derivative, times 2x minus x squared raised to the 3x squared. And this is just the derivative of the exponent, right? And then this is going to be x to the third plus 2 raised to the second power. And so this is where we end up with 4 times, sorry, not 4x, x times 4 minus x to the third power all over x to the third plus 2 raised to the second power, right? So I just used the power rule there. So then that means that f prime of x then is going to be the original function times g prime, which is x4 minus x to the third all over x to the third plus 2 to the second power. And then we can kind of clean this up just a little bit, right? And so then we can say, well, this is going to be x and then 4 minus x to the third times e raised to the x squared over x to the third plus 2 all over x to the third plus 2 to the second power. And so basically it's the same function, which is just be the original function times g prime of x, and that's the rule that is this one right here. That's the rule that we use to do that one. All right, let's go back. So number 40 is a word problem. So let's take a look at it real quick. I'm going to just kind of read it off the book, if you will. So for number 40, what it's asking us is the sales of a new personal computer in thousands is given by S of t is equal to 100 minus 90 raised to the times e raised to the negative 0.3 t. Where t represents the time in years, find the rate of change of sales after each time. So for A is going to be 1 year. And so what we have to find is S prime of t. And then S prime of t, remember, so let me just write it this way here real quick. So this is, we know that the derivative of 100 is 0, so we don't have to worry about that one. And so we know that y prime is going to be negative 90, negative 0.3 e raised to the negative 0.3 t, right? And then when I put it together, it's going to be 27 e raised to the negative 0.3 t. So then S prime of t then becomes 27 e raised to the negative 0.3 t. So then what we're going to find here is S prime of 1, which gives us about 20, and so it's going to be about 20,000 computers per year. Oops, no. 20,000 computers per year. The next one for B is going to be 5 years. So S prime of 5, it's about 6,000 computers per year. And then C, we can see that for C, they're asking us what is happening to the rate of change of sales as time goes on. So it's decreasing. And then part D, it says, does the rate of change of sales ever equal 0? So then C, this is just decreasing. as time passes. And in part D, what they're asking us, can s prime of t equal 0? In this case, it cannot equal 0. Now, as t goes, if we were to find a limit of s prime of t as t goes to infinity, it does go to 0. So although the rate of change of cells never equals 0, as it gets closer and closer to 0 as t increases all the way. So it converges to 0, although it will never be 0. So I believe the next one is 42. So let's look at 42. And so for 42, they're saying that, let me find 42. Product awareness. So after the introduction of a new product for tanning without sun exposure, the percent of the public that is aware of the product is approximated by, so let's go ahead and look at that one. So 42, the function that they give us is a of t is equal to 10t to the second power times 2 raised to the negative first power. Oh, negative t power, sorry. I read that. And so for number 2 here, y prime of t is going to be 10t to the second power, I gotta use the product rule, times natural log of 2 times t to the negative t power times negative 1 plus 20t times 2 raised to the negative t power. And we can clean this up a little bit, which would be 10 t raised to the 2 raised to the times 2 raised to the negative t power times negative t natural log of 2 plus 2. And so for part A, they're asking us to find a prime of 2, which is about 3.7. So it's about 3.7% per month of the public that knows or is aware. Part B is a prime of 4, which is about negative 1.93% per month. So then part C, it's asking us, notice that the answer to part A is positive, the answer to part B is negative. What does this tell you about the public awareness of this product? So public awareness first increases when the product is new, and then slowly decreases as the product's been in the market for a while. So, increases first, and then decreases. And so that is the lecture for 4.4. Thank you.